Hello everyone, today we continue learning Python and today I'll explain what is testing, how we can test things in Python and why we need testing. So let's start. First of all, that video is for the beginners in testing, for the beginners in programming, because if you know what are unit tests, how to use unit test library in Python, how to use Selenium, it's not for you. But if you want to get into testing and understand how we can test things, what we need to test and why we need to test our code, then that video is for you. Okay, so first of all, let's create a function called define, for example, sum. And I will append an underscore after the name of the function because in Python we have sum function. So sum that gets an interval and returns the sum. For example, 1, 2, 3, and it will return 6 because 1 plus 2 plus 3 is 6. And in Python there is a rule: if you want to use the same name but that name is already taken, for example sum is taken and I don't want to reassign my function, I can append an underscore at the end, and my sum function will accept two parameters a and b. So if is instance a integer and is instance b integer, will return a plus b, or else we'll raise, let's go right here, raise type error, which says a and b must be integers, like that. So what that function does, first of all, we accept two parameters and we check that both of them are integers. So its instance function checks that your object is the type of the second argument. So for example, a is integer, b is integer, it returns either true or false. So if both a and b are integers, we return a plus b, so they are sum. But else we raise type error. And I want to remind that if you want to use is instance function in your programs and you want to check that, for example, a is a number, not an integer, but a number, it's better to use abc module with abc.number or abc. Let's go right here, abc, not abc, but it's decimal dot, no, where is, let me import, I forgot where it is contained, number capitalized, and let's go right there, let's go, yeah, import this name, numbers number, yeah, we have that. So from numbers import number, that's a meta class for every number in Python. So if you want to use floats, integers, like any number, because in Python we have a lot of numbers. For example, import decimal and there is decimal class. So decimal.decimal class, which is also a number, and we can append integer to a float. And if you want to check if your object is a number in your real Python programs, then you should use is instance a number. But that's not the point of the video, and I'll explain that in the later videos. Okay, so if both of our parameters are integers, then we just print their sum. So let's go sum 1, 2. Now we should see 3 in our console. As you can see, 3 right here. But what if I'll provide not 2 but hello as a string? Let's run it, and as you can see we receive type error. A and b must be integers. So yeah, that's great, we wrote our function, it doesn't matter what that function has to do with our code, we just wrote it. Okay, let's delete it and let's go to the next function. But no, we should not go to the next function right now, because what we need to do after we wrote one function, one logical function, or one class, one piece of code, we need to write tests for that piece of code. So what I will do, I'll create another function, but not like multiply function, not like negative function, not a function that contains some logic for my app, for my end user. I'll create a function that is called test underscore sum, and underscore because of the naming I chose for my sum function right here. So test sum, what that function does? That function automatically tests all the returns, all the errors, everything in our sum function. And how we should test it? Well, the most obvious test technique is using ifs. So for example, if sum 1, 2 equals 3, I know that that should be true. Let's print OK. But else, if our function returns not 3, for example, 1 plus 2, and somehow we append 1 here, so we'll return 4. That's not ideal, because I don't want my function to return a wrong number. I want my function, my sum function, to return a plus b, and I know the logic of that function. Therefore, I can write tests for that function. And for example, if sum 1 plus 2 equals 3, everything is okay. But else, what we'll do, we'll raise, let's raise value error. Value error that says 1 plus 2 not equals 3. And now, if I run my function with a normal, let's call test sum function first of all. If I run my function with a normal a plus b, let's run it. As you can see, everything is okay with our test sum. But if somehow I append 1, let's run it again. As you can see, value error 1 plus 2 not equals 3. And now what we have? We have a simple test that shows us that our function is works not ideally. So we have some errors in that function. That means that we can automatically test all the functions in our code. And why is that much better than testing them by hand, as we did 5 minutes before? Because our function, almost every function, is not 4 lines long. You have many errors, many exceptions, many ifs, many loops, and so on. And because of that, there are lots of outcomes of that function. And you may not foresee all of these outcomes as a human, but your tests will do that, because you know what your function should return. So I know that sum 1 plus 2 equals 3 should return 3, and therefore I print OK. But else I raise value error. And now if I have a big project with a lot of functions and my sum function will be in almost every class, in almost every file, so there are lots of dependencies for that function, then what I'll do, if I'll change my a plus b plus 1, I'll receive, like, look here, you have value error, so your tests are not running correctly. That means that I should go to my function and change it. So a plus b, now everything is okay. So again, you should write tests for any function, for any piece of code. But now, what is not tested in our function? What is not tested is if we don't provide integers. We need to raise type error, but I do not test it anywhere in my test sum function. So let's do it. Try sum, and for example 1, hello, except type error, print OK, except anything else, so let's accept exception, and raise, or actually we can not accept exception, let's just raise value error right here, wrong arguments, no type error. I'll write it like that. So what are we doing in our next test or test case? We are trying to run sum 1 hello. So we provide the first argument as an integer, but the second one as a string. And if we raise type error, as you can see, we accept that type error in here. However, and we print OK. However, if no error was raised in our sum function, and that also may break some of our app logic, then we raise value error right here. And that's how it works. So value error is not accepted anywhere, and now let's run it. As you can see, both tests are okay. But if I'll change type error, or if I'll just comment it out, let's run it again. As you can see, wrong arguments, no type error. Because we provided the wrong arguments, but there is no type error. And of course, in the ideal world, you should also check that if both arguments are strings, if the first argument is string but the second one is an integer, if arguments are any other type, floats and so on. But that's just for the example. Okay, so now as you can see, our tests are not running, particularly one test. But if I'll change my function, I'll change its logic. Then, as you can see, everything is okay. And you should write tests for almost anything, but that is not the ideal test in Python. And you can write that type of test, so if, else, raise, in almost any programming language, because there are in almost any programming language there are exceptions, there are errors, and you can just throw or raise them, so you understand what I mean. But in Python we have much better syntax for tests, and it's called assert. So let's comment out our first and second tests, and let me show you how assert works in Python. So let's go with assert, and then what we should do is give the assert keyword true or false. So if I'll give true, let's run it. As you can see, I call my test sum right here. Nothing is happening. But if I'll give it false, let's run it again. Assertion error. So assert is a keyword that will raise an error if your logical expression returns false. So what does that mean? If sum 1 plus 2 equals 3, so that is a logical expression. If that is true, nothing is happening. But if I append 1, for example, in my sum function, let's run it again. As you can see, assertion error, because sum 1 plus 2 equals 3 gives us false, and that's how we can test things in one line in Python. And of course, assertion error it's not descriptive, because there is no message, but actually we can copy 1 plus 2 equals 3 from our raise value error, delete that, and append the comma and our message. So now, if my assertion error will fail, I will see 1 plus 2 not equals 3, and you can provide almost any message, any message you want in assert. So now, if I'll delete plus 1, let's run again. As you can see, everything is okay. And assert is not ideal, because I don't think of a better way of testing my type error than that. So try except type error. Of course, there is a better way using unit test library in Python, but I will not talk about that library today. I will talk about like the idea, the concept of testing. And in Python we have assert that helps us a lot. So we just changed 4 lines of ifs, prints in one line. And yeah, that's actually great. Okay, so now what I want to tell you. I want to tell you that assert is really a great tool, not for only tests, but for input checking. So there is Django framework library that uses asserts in a lot of classes, and if you worked with it, you probably received assertion errors one or many times. So what it does, for example, we accept A and B right here, and if you know that A and B can only come from the programmer, so our user cannot provide them, the only one who can is our programmer. For example, A and B are from our system environment variables, or from anywhere that, so A and B are the parameters that our user cannot access. That's what I mean. What you can do is, instead of is instance, you can use asserts, like that. Assert, and like that. Assert and return and remove that. So again, that can only be used if you are really sure that your input comes from your programmer only. So from the programmer that uses your code, from other programmers in your team, and so on. Because assert is not meant for if raise error. It's meant for only checking the input of the programmer, or for tests. So what we can do, or what Django framework does, it checks that some input that can only be provided by programmers is it's the true one. So it goes for every test. For example, we only can provide integers right here and integers right here for A and B parameters. And if that is true, then of course A plus B returns our result. But if that is not true, or if your A and B parameters can be provided by the user, for example, you're using sum like that, and then using input, then of course you should not use asserts. So only use asserts in tests, or when you're sure that your input cannot be provided by your user, by your end user, who will use your application, your web server, and so on. But of course, if you're writing a library, assert is a very great tool. And Django framework actually asserts a lot of cases and prints messages right there. So for example, let's run our sum function with, for example, hello, hi, like that. As you can see, assertion error, ASDL. So yeah, everything is great, and we only have one line right here. That's how it works. But again, don't use asserts as ifs, because that's not their aim, their general aim. Okay, so now we talked about that, we talked about asserts, and I want to finish my video with like the 5 rules of testing. So the first rule is that everything should be tested, and I made that rule in a lot of my projects because I write them for YouTube, and tests are quite boring. So yeah, they are quite boring. I write only one test and I can explain what it does, but then it's just the repetition of my previous work. Of course, there are tests that like very interesting, that show like how you can write tests, how you can structure a test, but that's just for one video. And I don't want to test my YouTube projects, so the projects I write on YouTube, my chats, my programs, because it will be boring for you. If you want to know more about testing, about unit tests, functional tests in Python, then write that down in the comments. But again, it may not be as interesting as writing like the raw logic, the raw business code for you. Okay, so the first rule, that everything should be tested. And of course, I do not test my projects in YouTube, but all of my other projects are tested. And yeah, I can omit tests sometimes from time to time, but that's only because I don't want them to be popular, or I just write them for myself. But if you work in a company, if you work in a business, if you work like actually anywhere, because that's not a very great habit to omit tests, you should always write tests. So that is the first rule of testing in any programming language. Next rule is that you should that rule is in almost every programming language, but it's a great rule. In Python, it's a requirement that you should start your test with a test underscore, or just a test if you're using that for file names. So you should start all your tests, all your test files, test cases with test word. Why? Because in Python, a lot of libraries, for example, again, Django, pymanage.py test. Manage.py is a file for managing your application in Django. So if you know what that means, you'll just test your whole Django application. So pymanage.py test will look through your files of your Django project and will only execute tests where your files start with tests. For example, test product or products, test users, test ideas, test anything else. Because again, a lot of libraries in Python look at your tests, and if they start from test underscore test word, then and only then they will be executed. And again, that is the rule, that you should start your test with test word. Okay, then the next rule is that you should write a lot of tests for one function. For example, there are 4 tests that I can see right here, or actually 5. First of all, that we accept 2 parameters, and that both of these parameters are required, because that's how our logic works. Then that we return the real sum for positive values, for negative values, for the first negative or the second negative value. That we return the real parameters for floats, for strings, for everything that we should test, for everything that we expect from that function, and everything that we expect should be tested. Okay, so that's kind of a rule. The second rule is, or the third rule is, don't write one test. So that is a very bad approach. What is better to do is use test sum, positive values, and then def test sum type error, like that. And actually, if we want to use like sum underscore, then we should append it like that. So yeah, again, you should split your tests in different functions, because it will be just easier for you to work and manage your tests. Because if my test sum positive values fails, I know that there is something with my a plus b, so positive values. Maybe I use minus a plus b, or maybe I'm using something else. But if my test sum type error fails, then I know that my code does not raise type error, and I need to look at that. And again, for every test case, for every test, you should write a different function. And I'll talk about that in the next video when we'll use unit test library. Okay, so that is the second rule. Of course, split your tests into different files, into different directories, and so on. The next rule is that you should not you should rewrite your test when it's needed. So for example, now we use test some positive values and that test works. So let's call it test some positive values from we do not expect nothing in here. Okay, let's run it again. As you can see, everything's alright. If I change something, +1, yeah, we have assertion error. So everything is alright with our test some positive values. But test some type error test is not alright because we don't raise type error anymore. So as you can see, some hello, yeah. So what is happening? Why we don't have raise value error? Wait a minute, someone hello, return a plus b. So nothing is happening right here. Raise value error, wrong arguments. But why don't we have any errors? There's some type error, assert. Let's go right there. Maybe, I actually don't know. Let's debug our code to see what's happening. So we call that. Oh, we have type error. Oh, okay. And what does it says as exception? Like that. Boom, boom, boom. Yeah, so unsupported operations for int plus str. Again, it's ideal that we'll test the message that is printed in our exception. But let's imagine that we need to append hello plus hello. So that will return true, but that's not ideal for our code. And as you can see now, wrong arguments, no type error. Yeah, so what's happening in test some type error function? Actually, our test is an old one. It's deprecated. We don't need it anymore because I decided that the logic of my sum function will accept any parameters. So I decided that I don't want to accept only integers. I want to accept any types, anything that can be concatenated, appended, and so on. And because of that, I removed all type errors, all ifs, all asserts, and so on. And now, what I need to do with test some type error, I actually need to rewrite the test. Or actually, I need to delete it because there is no need in that test for our function. Because again, when you rewrite your logic, when you rewrite your code, when you, for example, change your authentication method, when you change your user structure, when you change your directory structure, or anything, you should test that in your tests. And you should change your tests. So for example, if you wrote all the tests for your user application, but then 1 year later you need to change it, of course you need to rewrite your tests. And that is the nastiest part about tests because nobody wants to rewrite them. You already have a lot of tests, a lot of them do not fail, and you need to actually rewrite them. But actually it's not that big of a deal because most of the times you will not rewrite your whole application test, but you will write 1, 2, 5, 10, 20 tests, and all of them will work. Okay, so that is how we can test things in Python. Again, that is just an introduction, and it's not ideal because I have not talked about test-driven development. I have not talked about unit test, functional test, Selenium, for example, or tests in like different frameworks of Python, for example, in Django, in Flask, and so on. So if you want me to talk about tests, to talk about how you should structure a test, how you should work with your test, and how you should test your applications, then of course leave a like and write it down in the comments. And yeah, that's actually everything I have for you today. So thank you for watching and good luck.